Well, I don't feel like doing this right now. Maybe in my off time. But anyway, I'm having trouble with the virtual reality buzzer, so I'm going to move on to the next project. Wireless game controller. Create a working design. Right, from Carl. I'm wrapping up a project to make a game console and could use some assistance. Before you get too excited, it sounds far more fun than it actually is. The console is just a tiny, super cheap box we're making for sleep cubes. Big Japanese capsule hotel chain to stick in every pod. The end will just be some free dross they find, I'm sure. At any rate, I've got it mostly done. I just need a module for the little wireless controller that comes with it. I ping you, you tell me what's going on, nothing more, much more than that. So I'm going to try and start work on a design for it. Oh no, it uses another one of these modules. Okay, X and Y are simple inputs connected to a joystick. A and B are simple inputs connected to buttons. Radio RX is a non-blocking X-bus input connected to a radio receiver. Radio TX is an X-bus output connected to a radio transmitter. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure to use the most recent input values. Ah, okay. So, and X and Y, X is 0 if A is 0 and respond with 0 if A equals 0 and B equals 0, 1 if A equals 100, B equals 0, 2 if A equals 0 and B equals 100, 3 if A equals 100 and B equals 100. Okay, so we get input from radio bus RX. When we get a -1 from it, we need to respond. Otherwise, we just need to not do anything. So we might be able to handle this with a few microcontrollers. Testing the input here. I don't know, this might not work as I had hoped. Not sure what I was thinking here. Because we need to be able to move X and Y. Okay, well, actually, this might be workable with. No, wait. I mean, because I need this to be able to read in X and Y, which and A and B, but it also needs to be able to move output to this. It needs to be able to take input from this and output from this. This might be a lot easier if I had the MC4000X, because that's just 4 X-bus ports. I don't know, what if I just start like this? Okay. But I don't know, I'm getting multiple we have multiple. Okay, we've got an input and an output. Okay, wait. Might be possible. Let's see. Okay, so. Okay, wait, yeah, no, we could probably handle this part here. Okay, so. Let's see. 0 accumulator. Wait. Okay. We need to be able to check states. Or test greater than 0, 0. It is. Then add accumulator. Then x greater than t1, 0, add accumulator, and move accumulator to x0, sleep 1. Okay, so now this should report as to, because in this case, if A, okay, so if neither A or B is pushed, then it should send a 0 value out. And if A is being pushed, it adds 1 to the accumulator. If B is being pushed, it'll add 2 to the accumulator. And then it'll output the value of the accumulator to here. Problem is, how am I going to send 2 values from here to this controller? I don't know. Clearly my math background is failing me now. There's a lot more programming than I thought it would. Well, I mean, I know it's a lot of programming. I'm just trying to figure out how to get this to work. Or at least in a way I think it would work. Okay. I'm flipping through the manual here, trying to see if there's a reference for the RF. Oh, yeah, here it is. And actually, you know what? I'll bring it up on the data sheets, because what we're looking at is right after the Denver timekeeping chip. It's the C2S Chennai Com Solutions. Alright, so, yeah. If you need an easy and effective wireless solution for your embedded system design, Chennai Com Solution has the answer in the form of the C2S RF901. Low-power RF transceiver with built-in antenna and auto-sensing RF switch. The C2S RF901 sends and receives data over a reliable wireless link using a dual X-bus connection. Non-blocking buffer. All data received is passed through an internal non-blocking buffer. Reading from the C2S RF901 when no data is available will yield a value of -999 instead of blocking until data arrives, which is typical S-bus behavior. With the C2S RF901, you can keep working while you wait for data to arrive. With transmit and receive pins located on the same side of the part, you will never find yourself moving components in an awkward way to accommodate the C2S RF901 in your design. Just place it down and don't worry. The best solution for wireless. Indeed, the C2S RF901 is a true turnkey solution for wireless communications that you will find yourself using every day. When it comes to wireless, don't be a prozoan, just get yourself a C2S RF901. Okay, well, I'm thinking about that. Well, okay, now there's not more information on this one. Oh, okay, so output is coming from here. Okay, let's get rid of all this. Okay, so test less than x0, 0. Because we need to be able to actually use it if it's loop. Otherwise, oh wait, no. If it is, and if it's not, jump. I don't know. Okay, so move 0 accumulator. Then I don't know, test compare accumulator to 0. If it's greater than 0, then it's 1. So move 1 to that. Test equal, or not move 0 to that. Test equal 1. That is move 100. Oh wait, or move. Equal 1 dat. Move 100 to P1. Sleep 1. 0 P1. Sleep 1. Oh wait, no, jump start? No. Okay. I don't know, is this back to where we were? Alright, well, let's step through. Okay, negative 9 to 9. Okay, we had a 1. Wait. 1. No, something went wrong there. Huh, how'd that go wrong? Okay, once more. Select 1. Test listen. 0. Yeah, well, it is, but. And so it jumps into the loop, but. Okay, no. Want it to be pulsing if it's in a 1 state, and not pulsing if it isn't. Okay, well, I know what I wanted to do. I'm not sure how to get it there. It needs to be able to hold a state. Oh no, if it isn't, maybe if we negative. Alright, jump, end, sleep 1. Okay, let's try that. So, this way, we move in. If it's negative 991, then we just jump to the end and sleep. Then jump to the end, sleep, then move a 1 in. So move 1 to dat. Oh wait, but then it moves a 0 into the dat. Okay, so now if it's not less than 0 here. Okay, well, let's try this. I want to see how it turns out. Okay, so it's accumulated as 1, 1 to that, which means we need to start pulsing. Okay. Oh, if it's not, then I think I need to move a value of 0 to that. Move 0 dat. Okay, let's try that. Okay, stepping through. And yeah, okay, I think that's working. Okay, it looks solid. Let's run it. Yeah, okay, I figured out how to make a loop. There we go. Minimal cost, well, average cost looked like. Not quite the most common power usage, and I used, well, about as many lines of code as most people. Alright, well, return to email. Wonderful, this is exactly as I had imagined it. I don't know what that character is, but he's repeated it. Okay, so yeah, great. Now I have to work on this one. Okay. Okay, so I can send one state out through here. But how do I... Oh, verification. Okay. Okay, well what if... You know, this needs to keep working while it's a negative 999 state. But when a negative 1 comes in, that's a request. That's less than x3, negative 1. And if that is the case, jump, end, sleep 1. Actually, that's the time limit for this. So I'm going to be calling it there and thinking this over, coming back to it later. So thank you very much for watching. If you enjoyed the video, make sure to leave a like, maybe a comment down below on what you liked. And if you'd like to see more from this channel, make sure to click the subscribe button. So until next time, I shall be saying, fare thee well.